inequalities. We're not going to start out with a rational. Rational means fraction. We're going to start out with a quadratic inequality so we can get an idea of what we're actually doing here and what we're looking at. So everybody, what this says, let's read this. Everybody looking up here. When is this quadratic less than 0? It reads, when is this quadratic below 0? So everybody look. That means for y, where is the function below 0? Where are y values below 0? So look, aren't these the y values below 0? Yes. Yeah, so our solution will be an interval from here to here. Well, how are we going to find those values? Plug what in?
Find the root.
Oh, plug it into the calculator and find the roots, but we're not going to plug it into the calculator. We're going to do it by hand. Okay, so let's factor it. We'll multiply to be negative 10 and adds up to be 9, 1 and 10, and then negative 1, correct? We got a long factor, so we have 2x squared plus 10x minus 1x minus 5. Factoring by grouping, we already know how to do this, so I'm going to go quick. Pull out a 2x, left is x plus 5. Pull out a negative 1, x plus 5. So we pull out our x plus 5 and left is 2x minus 1, so our two zeros are x equals negative 5 and x equals a half. So we can go put those in. Negative 5 and a half. So our solution would be from negative 5 up to a half. Now the question is it equal to 0 as well in our solution set? Yeah, because the little equal sign. So this point and this point equal to 0 gets to come into our solution set, so that would be a bracket instead of a parenthesis. So if I was to scribble that out, we would have just had parentheses because right on 0 it's not included. Does that make sense, everyone? Yeah. Now guess what? We just solved by graphing. Now let's change this problem to a rational, fractions. Do you like to graph these rationals? No. Not really. They're kind of hard. Isn't that what we learned last time? They take a long time. So what we would have to do is we'd have to graph a rational, these big, we'd have all these asymptotes, we'd graph it, and then we'd have to see where it's below 0. That's going to take a long time. Let's do it an easier way. Agreed? Yeah. So let me show you how we would have solved this one without graphing, and you do the same thing with the rational. So instead what we would have done is pretended this graph was not here, and we would have just made an x chart here, an x-axis basically. So we're going to test values for x, because we're just going to plug in values for x. So we're going to use our critical values, which are the zeros. Now why is it zeros that are our critical values? Because this says, when is the function below 0? So that's why our zeros are the critical values. So we're looking below 0. So we would put in negative 5 and a half. And then guess what? All we have to do is just literally plug in values and see if it's a true statement. So let's plug in, everyone has a calculator, let's plug in negative 6 and see if it's a true statement right here. So you'll do 2 times negative 6 squared plus 9 times negative 6 minus 5. Is that less than or equal to 0? So 13 is not less than or equal to 0. So no, this part of this is not in our solution set. Then we plug in a value between negative 5 and a half. Let's plug in 0. So wouldn't that be negative 5? 0, 0, right? Is negative 5 less than or equal to 0? Yeah, so we'd write yes. That part is in our solution set. And if we plug in a value like 1, that would be 2 times 1 plus 9. So that'd be 11, right? And then 11 minus 5 is that less than 0? No, so this would be a no. Now, one more thing. Were the zeros yeses or no's in this one? They were yeses because of the equal, so we're going to write yes under here and yes under here. And then look, yes is our solution set. So from negative 5 up to a half is where it said yes. Easy, right? Just testing values. So we're going to do it by that method. Now, what if this would have said less than or equal to 3? We would have had to do, instead of 0, we would have had to do 3, and then it would have been a lot harder to do. I would have rather done 0, so what I would have done is subtracted 3 over and then done it that way. So that's what we'll do with these rationals. We want to look at zeros. Zeros are the easiest. Writing this example down. So we have x over 4 minus x is less than 3. So what we would have to do if we were going to do this by graphing is graph this rational and then see where the function is below 3. Like for y of 3. Below 3, but that'd be hard. Instead, let's do zeros. First of all, zeros are easier, and so let's bring this over. So let's subtract 3. So we have x over 4 minus x, and then we have minus 3 is less than 0. Now, when we're dealing with rationals, we want one rational instead of two separated rationals. So to do that, we need to get a common denominator. So we'd multiply by 4 minus x. 4 minus x, we want one rational. So now we have in the numerator x, and then we distribute the negative 3 through. So negative 12 plus 3x. So on top we have this. 4x minus 12, and on our denominator, in standard form, which would be more appropriate to write it, would be negative x plus 4. We want to know when does that rational function less than 0. So think about this. When is this function below 0? So what we're going to do is come up with some critical values. Now because we're testing below 0, we can find our critical values are going to be our zeros. Can anyone remember how we find our zeros of a rational? Where do they come from? The top, the numerator. So that is going to be our first critical values. The numerator, those are the zeros. So what's our 0 here? 3. X equals 3 is a 0, so 3. So that's going to be a critical value we have to test. Now in rationals, because it's a fraction, there's another critical value. We cannot have a denominator of what value here? 0. So we can't plug in a 4, right everyone? So also for rationals, a critical value is the discontinuities. So for rationals, we just have to add in an extra thing, the discontinuity. So x equals 4 would have been our discontinuity. So we have to test 3 and we have to test 4. Those are our critical values. How we should have probably written this was in factored form, just because look how much easier that would have been. Negative 1 and x minus 4. So just saying, factored form is probably the best way to look at it. We did get the same answer though. Okay, so let's start plugging in values. So somebody plug in a value below 3. Wouldn't 0 work? So let's plug in a 0. We can plug it in here or here. So look, 0 minus 12 is negative 12 divided by 0 plus 4. So is negative 3 less than 0? So let's write yes. Now let's test between 3 and 4. So that would be plugging in maybe a 3.5. Everyone do it. 4 times 3.5 minus 12 divided by negative 3.5 plus 4. So we got a positive number when you plugged in 3.5? So is 4 below 0? No. So we'd say no here. And then plug in a 5 maybe. Well, we don't even, look, we can just picture it because this one's easy. 4 times 5 is 20. 20 minus 12 is positive, correct? Then on bottom we have negative 5 plus 4, which is negative, a positive on top, and a negative on bottom would be negative, which is below 0, so we'd say yes. Now next thing is we do need to go to these critical values and say if they're yeses or no's. So was it or equal to 0? No. So our zeros are not included. Our 0 was 3, and because it's not including 0, we'd say no here. The denominator is always a no, because we cannot be 4. There's no possible way. So now just write it in interval notation. So our answers were from negative infinity up to 3. Those were the yeses, not including 3. Union, and then from 4, not including 4, to infinity. There's our answer. If you were to graph this rational right here, you would see, and we would be able to, you would see that on those intervals, the function is below our x-axis. Okay, another one. A couple more examples, we'll fly through them, and then you'll be good to go. Solve the inequality. Once again, we're really going to want to do 0. Because zeros are easy to find because they're the numerator. So instead of having it like this, we want it to be 0. So I got to bring this over or these over. So shouldn't we just subtract that over? Subtract x plus 5 over x plus 2. So then we have this, x plus 1 minus x plus 5 over x plus 2. And we want to know when is that greater than 0. So once again, we're going to need one rational, so we need a common denominator, so we'd multiply by x plus 2. With two terms, you need parentheses, so now we're multiplying out and combining like terms in our numerator. So it looks like we're going to have x squared plus x plus 2x, so that's plus 3x's. Then we have plus 2. Then we distribute our negative through, which is minus x minus 5. In our numerator, we have x squared. Then it looks like we have plus 2x. And then we have minus 3. And in our denominator, we have x plus 2. And that's it, right? Okay. So now and we want to know when is that greater than 0. Let's factor the numerator because it's easier to find the zeros that way. We'll multiply it to be negative 3 and adds it to be 2, 1 and 3, negative 1. So now I have this. X minus 1, x plus 3, all over x plus 2. We want to know when is this function greater than 0. So let's make a number line. And what are my critical values? So you're saying 1, and then Okay, I'm going to make this one the -2 to give myself some room. So then 1 over here and then -3. Okay, let's test values. This is the one that last hour we had a rough time with, so everyone, help me out here. So pick a value. Somebody go and plug in a value below -3. A couple of you, many of you. Then somebody pick a value between -3 and -2. So that'd be like -2.5. Then a value between -2 and 1, and then a value above 1. And then you're going to say, below -3 is a yes or no. And then between -3 and -2 is a yes or no. That's how you'll tell me. Between -2 and 1 is a yes or a no. Ready, go. A few of us need to do it. Did anyone else get yes for below -3? Okay, yes. So somebody got a no here. You got a what here? Wrong. It's a no. But you guys got to be able to plug them in or you can't do your homework. So everyone again. Plug in. -2.5, everybody. Right here using parentheses. I swear we got a no last hour. It's a no. Then we've had 2 people tell me that it's a yes here, so I'm going to go with it. And then above 1 is a... Above 1's a yes?
Above 1 is above 0.
What?
That can happen, but I swear there was 2 no's in the last 2 hours. OMG. Above 1 I'm getting told is a yes for sure.
Yeah.
Okay, well there's too many yeses here. That's not true, that could be right, but I just remember from the last 2 hours there was 2 no's in this one. Yeah, not necessarily. Okay, video, we do not know how to calculate values, so forgive us. Okay, really, these are all wrong. Wrong. Okay. So, everybody, what the heck is your dealio?
Do I need to teach you how to type it into your calculator?
Compare. When you plug in -4, you get -2.5. Is -2.5 greater than 0?
No.
So this is a no. Then when we plug in -2.5, we get a value larger than 0, just so you know. So we'd say yes. Then when we plug in 0, guys, you get -1.5. Is -1.5 larger than 0?
No.
Okay, and then when we plug in a 2, we get 1.25. Is 1.25 larger than 0? Okay, so now our real answers are this. From -3 up to -2, not including each of those, correct? Union, and then it would have been from 1 to infinity. Are we all okay out there?
Yeah.
Okay. Let's do another one. Yes. I know, I didn't know who to listen to because there were so many yeses and nos. Now I know that I should listen to you. Okay, another one. Here we go, everyone. Let's do better this time. Let's go quicker and do better. So we're going to want it equal to 0, so we have 6 over x plus 2, and then we have plus 3 over x minus 7, and we want to know when that's less than or equal to 0. We need a common denominator, so we'd multiply 6 by x minus 7, wouldn't we? Plus 3 times x plus 2, this is the numerator, so that's 6x minus 42 plus 3x plus 6. So then isn't that 9x minus 36 all over the common denominator of x plus 2 and x minus 7, right? So when we pull out a 9, we get x minus 4, and then on bottom we have our x plus 2x minus 7. Yeah. -42 plus 6, though. Yeah. And we want to know, that's okay, it's a good question, and then we want to know when is that less than or equal to 0. So what are my we should go way quicker through this one. My critical values are at 7, aren't they? At 4, and at -2. So now we're going to plot values, plug in a -3, plug in a 0, plug in a 5, plug in an 8. We can do this. Okay?
Wait, are we sure though that?
Yep. Because everyone's being extra careful this time, I just know it. Yeah, well, you should be. Because if we have to go through this again, what? Above 7 is a yes. It says when is it less than 0? Yes.
Between negative. Wait, less than We're talking about below 0.
I need 2 verifications on each before I write down yes or no. You got nowhere.
No.
Above 7's no. Okay.
18 over 5 is not below 10. Or is not
This is no? Okay. Okay, yes. And you're sure that right here wasn't a yes? You're absolutely sure.
Okay, guys. Look at the sign before you start saying no and yes. Every time. Look at the sign.
I just don't know what's confusing, but that's okay. Okay, awesome. Here we go. Now we got to determine if these critical values are yeses or no. So is that we're equal to 0? Yes. So you'd say your 0 is a yes, and then our denominators are always no's. So now we would say, okay, my solution on this one is negative infinity up to negative 2. Negative 2 was a no. Union. Then it was from 4 to 7. And then 4 gets a yes, so that's a bracket. 7 is a no, so parentheses. Are we good with that? Okay, this is the last thing we're going to look at. We won't even go through it. We'll be done if you can just see the difference. There's a reason I'm doing this one, because you're going to be asked something like this on a test. It says, state the domain of the function. So I'm going to remind you of something. The square root of a negative number is not correct, correct? We can't do that, right? On the real number line, that is, right? The square root of 0 is okay. The square root of a positive number is okay. So our domain, it would be true to say, what's under a square root needs to be greater than or equal to 0, true? So you're saying that x minus 3 over x plus 3 needs to be greater than or equal to 0. And then how would we solve? The same thing we just did, right? It's the exact same thing we just did. You'd say, okay, to solve an inequality, I find critical values, which at this one are at 3 and at negative 3, and then we test values. So it's no different. It's just we had to set up the inequality. So it's asking you the domain. Yes?
Wouldn't you put x minus 3 is greater than or equal to 0 and x plus 3 is greater than or equal to 0 separately?
Dope. Good question. If you do that, you won't get it right. Because I had someone in 1010 the other day do this problem, and they tried that, and it's not
We
right.
have Alexa Hoffman to attendance for checkout, please.
Yes.
I was on that like
I was just zoning out. Sorry. So I was thinking about his question. I've done that to Robert today too. He came in and he was like, thought I was glaring at him, but I was just thinking about this. Okay. So I was thinking about why this wouldn't work versus why this would work. So let me explain. I'm trying to think. So, because they're not, we have to, how do I explain why you can't do them separately? If you try them separately, you'll see that it doesn't end up working. I can't think of why it's right now, because I'm like mind blank for some reason. But it doesn't come out the same. Because if you did it separately, you'd say x minus 3 is greater than or equal to 0, true? And then you would have said x plus 3 is greater than or equal to 0. Is that how you would have done it? Yeah, and then you would have added 3, so you'd say x value is greater than or equal to 3. Then right here you would have said subtract 3, so x value is greater than or equal to negative 3.
Yeah, so then you could name it all
Above 3, so that's not right. So I can't think of why that. I think it's just we're not taking into consideration that it's irrational. If we do it like this, we're just separating out and treating it as linear, but it's not, kind of. I don't know. So right here, we would test the values, and we would get yes, no, yes. So then we could say our domain. You'd say negative infinity up to negative 3, union, and then 3 to infinity.
But if you plug in negative 5, then you don't get a real number.
If you plug in negative 5, that's a negative on top and a negative on bottom, making it positive.
But when you square root of fractions, don't you like separate the square root? You know, so you have like the square root of x minus 3 over the square root of x plus 3.
But you were talking imaginary versus real, right?
Okay.
Right? Because we can have fractions under a root, right?
Okay.
Because even if we plug in, so we have the square root of but we wouldn't split it up because it is this, right? We split it up once we get a whole number. Like if we have the square root of 8 over the square root of 10, we can split it up, but we wouldn't split it up like this. I see the question now. Okay, awesome. So Needs to be greater than or equal to 0. We would make our little number line. Okay, awesome. That's the end of the lesson.